Students, welcome again. Let me do a little bit advanced problem and pulleys with you today. So, a combination of pulley and inclined plane problem. So, let's take an inclined plane which is like this, an inclined plane like this of angle 30 degrees. The inclined plane is at an angle 30 degree. There's a pulley on the inclined plane and this pulley is called A. This pulley is called A. Now, this pulley is connected by a string to a mass M, to a mass capital M. It's connected by a string to a mass capital M, and this pulley in turn supports another pulley which connects two masses M1 and another mass M2. So now it has been said the problem is to find the acceleration of M1. Now what are the masses? The net mass, let M have a mass of say 80 kg. The pulley A is massless, so I write this as 0. Say the pulley B, the other pulley which I'll call B, has a mass of 1.5 kg and M1 has a mass of 10 kg and M2 has a mass of 12 kg. So now what will be the acceleration in M1? That's what we have to find out. So let us see this. This M is 80 kg. This mass has a weight acting downward. So this is capital Mg. If this is capital Mg, this component is, this is 30. This component is Mg cos 30. But we are not interested in this component. We are interested in this component. This is Mg sin 30. So now if I calculate the value of Mg sin 30, so Mg sin 30, how much will it be? So 80 into 10, G is 10, divided by sin, multiplied by sin 30, which is half. So this will be 400 Newton. And this mass M1 is 10 kgs, M2 is 12 kgs, so total is 22 kgs, plus the mass of B is 1.5 kg, added to that will be 23.5 kg. So this whole system has a force of 235 Newton. So we see the net force in this direction is more. So the whole system will be moving in this direction with an acceleration A0. Similarly, since this is the same string, this part of the string will also be moving with an acceleration A0 in the upper direction. So now let us resolve the tension. Tension in this string, let it be T1, it's a pulling force. So it pulls in this direction, this T1. Pushing would be like this, pulling would be like this. So tension is a pulling force, so it acts along this direction. On the same thread, the tension will be the same. So this again, for this pulley, that will be a pushing force. So this will be T1. Here, this would be a pulling force. So this would be T1, this would be a pulling force, this would be T1. Now this string is different from this string, so tension in this string will be different. This will be T2, this pulling would be T2, here the pulling on the pulley will be T2, and here the direction will be T2, and on top of that you will have the weights acting downward of M1 and M2. Similarly, you will have a weight of B acting downward, MBG. Now if I write the equations for each of the individual body, let me write for mass M. For mass M, what do I have? The acceleration is along this direction, so I can write capital M A naught is equal to mg sin theta is also along this direction, so it will be mg sin 30 minus T1, because T1 is in opposite direction of A naught. What about A is massless, so it will have no equation. Now let us come to body B. For body B, we consider this body to be moving. This body will be moving since it's attached to this string. The pulley B will be moving upward with acceleration A naught. So for pulley B, you will have, since it's moving upward, you will have MB A naught equal to, now T1 acts on this, so T1 is in upward direction, so T1 minus these two T2s act in downward direction, so this will be minus 2 T2, and the weight acts in downward direction, minus MB G. Now let me consider that the block M1 has an acceleration A1 in this direction and M2 has an acceleration A2 in this direction. So when I write for mass M1, acceleration is along this direction, so M1 A1 is equal to, T2 is along this direction, so T2 minus M1G is downward, minus M1G, and for mass M2 you have acceleration is this direction, so M2 A2 equal to, T2 is in this direction, so T2 T1 M2G is opposite, minus M2G. Now how about the relation between A1 and A2? So in normal case, see, this whole system is moving with an acceleration A0, and M1 has an acceleration A1 and M2 has an acceleration A2. So in order to find out the relation between A1 and A2, we must bring this system to rest. So how do we do that? We subtract A0 from A1 and A0 from A2. So we have A1 minus A0 equal to, since if this mass moves upward, this will move downward, and if this moves downward, this will move upward. So the sign of A1 and A2 will be opposite. So this will be minus A2 minus A0. So we have the system of equations. We have 1, 2, 3, 4 and 5 equations, and using these 5 equations we can solve them and obtain the acceleration A1 of the mass M1. That's all for now. If you have any questions, please write in the comment section. Thank you.